All right. Good morning, everybody. Welcome back to Comp 2450 Software Development 1. I hope that you are all having an excellent day. When I was coming to work this morning, I saw a beaver. They are not majestic looking creatures. They are not majestic at all looking. I don't know if you've ever actually seen a beaver in person before, but they are just like, they kind of waddle and they lumber around. I only saw it briefly, but they're not majestic looking creatures on the ground. I saw one once. I was standing on a bridge and it was swimming in the creek. That is a majestic looking creature. Waddling around in the ground, not so much. Yeah. Welcome to Introduction to Animals around Winnipeg. I hope that you're all doing it good today. What I want us to talk about today is to continue thinking about this idea of implementing our domain model. So in class on Monday, what we did is kind of start up our IDE, get familiar with the idea of some of the stuff that our IDE can do for us, thinking about logically and physically organizing files and classes into packages. I want to continue thinking about implementing stuff today. And what I want us to be able to do today in terms of implementing stuff is I want you to be able to choose and use appropriate language structures for representing domain model objects. So in Comp 1020, we just did class for everything. In Comp 2450, we're going to introduce some new ideas to you, and I'm going to reintroduce interfaces to you. In Comp 1020, the learning outcomes for Comp 1020 are very much, you should be able to use an interface, implement an interface, here's an interface, implement it, and then be able to use it as variable types. I want us to spend a little bit of time thinking about when do we actually make that decision ourselves? How can I make choices about that? I also want to introduce some Java-specific stuff that will help us think a little bit about some of the intent that we have about the objects that we're going to be working with. The other thing that I want you to be able to use to do today, and this is a lower priority thing for me, so if I don't get to this point, that's okay. I'm not too concerned about this. I do eventually want us to be able to design and use a generic interface in Java. So generics in Java, as a small preview here, when you're making an instance of ArrayList, just quick thumbs up. I need to know where you're at in 1020. I've made an ArrayList before, and you put the angle brackets on it. Okay, that's what I'm talking about. Generics. That's what I'm talking about when I use the word generics here. I want to be able to pass a type as a parameter to another type. And so we may get to that point, but I'm not too concerned about this in terms of being able to get to it for today's lecture if we don't quite make it there. So I want to start by kind of giving you a clearer definition of what I mean by language structures here. We're using Java in this class, and Java is a language that has types built into it. And so when I'm using this word language structures, the structure being the keyword here, what I'm trying to say is that this is the kind of types that our programming language gives us to make complex composite objects. Different programming languages have different kinds of types that they will give. Python, for example, has classes, and that's it. And even that is kind of like a little bit wishy-washy because in Python, everything can be anything almost. In C, we have primitive types. So the primitive types that you're familiar with, integer, floating point, characters, but not strings, characters. And then we have things that are called structures. Structures represent something that's kind of like a class, but not really. Have you started doing C++ if you're in 2400 right now? So 2400 has classes, and it has a bunch of other stuff, and it has so much other stuff. How many of you have ever heard of the video game called Katamari Damacy before? Anybody? Okay, I am immediately digressing in class today. Forgive me for this, but I'm the one up here, and so I get to do the stuff that I want to choose. Katamari Damacy is this game. It is bizarre. It is bizarre. It is bizarre. This is an hour-long video. We're not watching this all, but I do want to kind of get to... Oh, this is just the soundtrack. Thank you, thank you, thank you. Oh my gosh. Sure, no commentary. Excellent. I don't want to hear you talking about this. Here. The premise of Katamari Damacy is that you're this little blue person, and you basically run around and you're just like the ball gets bigger and bigger. And you can tell John or Dan that it's 1, 2, 3, but I believe that C++ is Katamari. It is just like over time it has collected more and more and more and more and more and more features, and it is such a huge language right now that it is immense. Your success in this game is measured by how big of a score that you've made by collecting everything. You can see that this is just like collecting all sorts of swans for some reason around the room. And this is the king of the universe, and there's like a really long name to describe what this character is. So we have a piano lesson now. This is a weird game. It's a really, really weird game. I'm not sure that I would advise you play it. Anyway, programming languages in general have the kinds of types that you can use to build these complex composite objects. And Java is no exception here. For us in Java, for the things that I want to talk about today, this is going to consist of 3 different types beyond the primitive types that you know about and beyond the class, keyword as a type. I want to talk about interfaces. I want to reintroduce the idea of an interface to you. I want to talk about records in Java. This is something that's fairly new in terms of Java as a programming language. And I want to talk about enumerations. Enumerations are something that you may have seen before, you may have used before, but I want to formally talk about this idea of what it could possibly represent in a system. So let's start with something that you've seen before. Interfaces. An interface in Java is effectively a declaration or a description of just behavior. It does not in any way describe how something is actually implemented underneath. All it does is it says, if a class implements this type, then it has these methods. And this is what the methods approximately mean. Usually in the context of data structures like a set or a queue or a list or a stack, these are operations on that abstract data type. I want to be able to push. I want to be able to pop. I want to be able to add. I want to be able to remove. We're just describing the operations or the behaviors that you can apply to the thing without actually specifying how it's implemented internally. So what I would like to do is to take a look at an example. I invite you to program along with me if you want here. Last class, we were using Pokemon as an example. Now I want to switch back to using this music player as an example so that we don't get too tired of Franklin telling you about Pokemon all the time. So I'm going to go to my editor here to IntelliJ. And what I'm going to do is I'm actually going to import a project from version control. I put a link to the repository that I'm going to start from under today's lecture notes on the course webpage for our section. But if you want to follow along with me here now, I will just say what I am typing so that you can kind of type it along with me. So I'm going to be cloning this from a Git repository. And the URL that I'm going to type in here is https://code.cs.umanitoba.ca/fall2025/2450-fall2025/MUZAK. So 2450 MUZAK. Again, this link is on the course webpage for today's lecture notes. So if you haven't got a chance to type that in very rapidly, you can find a copy of that link. And if you click on it, you can copy and paste from your web browser into this URL field. So I'm going to click clone now. I'm going to open it in this window. And the very first thing I'm going to pop open here is the README, because that's pretty much all that's in this project right now. That did not help. That just made the text really, really small, and it did not change the size of the diagram itself. I will scroll this over just a little bit. Okay. So the domain model that we've got here is a little bit more of what we had when we started to do domain modeling. This was one of the first exercises that we did where we added these three main ideas. And what I've done to this domain model is to start to add a little bit more to this than what we had when we first had just circles with names and arrows between them. But the idea here is that we're trying to build some kind of software that's going to work with songs so that I can organize them into playlists. One of the things that I want to do with this setup is I want to be able to play a song eventually. I want to be able to play a song eventually. And the way that I want to be able to play a song is that I'm going to have different kinds of devices on my system that may be able to play songs. So I may have speaker on my system. I have a speaker on my laptop right now. I may have headphones that I want to play on. I may have something else. So what I want to do with this system right now is I recognize that I'm going to have a few different options for actually implementing this, and each of these different options will have different mechanisms for doing what they actually want to do underneath, but I want them all to have a common way to interact with them. I want to specify the behavior without actually defining how that's all going to work. And so what I'm going to do to this system is I want to start by adding a new type to it. And the type that I want to start by adding to this is called a song player. I'm going to put this in my mermaid diagram right now. So I'm going to scroll down, and I'm going to add this beneath everything else here. I'm going to add a new class that's called song player. And I'm going to assert to you that I am going to be adding this as an interface. I want to say this is the behavior that I want to have, and there are going to be multiple different kinds of implementations of this thing. So I'm going to have a song player. I'm going to indicate in my mermaid diagram that this is an interface by adding some markup here. So these two angle brackets say that I want to put a special indicator on this, that this is going to be an interface. And so I'm going to say interface here, interface. And if I scroll down a little bit or to the side, wherever it's put this, we can see that if Franklin can spell interface correctly, that it marks this up as saying that this thing is going to be an interface. This is technical language. That's okay, because we are all technical people right now. We are talking about implementing this thing, and we're not talking to somebody that's like helping us decide what all this stuff is going to be. What I want to have on the song player interface is going to be a single method that's called play. It doesn't return anything. And I'm going to write a comment here that effectively says, the behavior I want to describe is that I want to play a song. So my interface here says I only want to say you can call this method on things that implement this. And how they do that thing is kind of up to them. It's kind of up to them to do. I would also like to add a couple of implementations here of this interface. I'm going to start by just adding one. I'm going to say that this is a speaker song player. I'm going to say that the speaker song player internally has an instance of a song. And it is going to implement this interface. So I'm going to say that it has a public method called play that has a return type of void. I want to connect these two ideas together I want to say that the speaker song player is going to implement this interface, so there's some connection between the two of them. And the way that I'm going to indicate that in my mermaid diagram here is to use this syntax, speaker song player. And I'm going to do dot dot pipe arrow angle bracket, and then the name of the interface that I want to implement here, so song player. This syntax here, dot dot pipe greater than symbol, this word says this materializes, this class materializes this interface. It actually does the thing that this interface says. So the actual keyword here is materializes. But for us, this means implements. Implements being the keyword in Java that says I'm going to implement this interface. I also want to say that the speaker song player is related to song. It is. Okay, on one, there's two options here, a composite or an aggregate relationship. And I'm going to ask you all to shout out the word composite or aggregate on the beat of 3. After 3, I'm going to say the word 3, but we're going to keep on the same beat. The relationship between song player, speaker song player and song is one of aggregate or composite. 1, 2, 3. Aggregate. Okay, good, excellent, aggregate. So I'm going to say that this is -O here to say that it's related to song that way. Thank you. I am so happy that you all said anything, honestly. I'm so happy that you all said anything, and I'm really, really happy that you're all generally saying aggregate. So awesome. Okay. So I've updated my domain model here, and now I want to actually go and add these things to my domain model. So I'm going to go to my file explorer. I'm going to add a new package under my main package here. I'm going to call this one model because these are going to be model classes. I'm going to make a new interface. So Java class, I'm going to choose this to be an interface, and I want this to be a song player. I'm going to say don't ask again, and I'm going to click cancel because I prefer to do this on the command line rather than doing this with IntelliJ. My interface here, what I wanted to implement is just public void play. And I'm going to add a comment here that says play a song. How we play the song is not specified. I'm going to make a new class. I'm going to call this speaker song player. I'm going to say that this implements song player. Implements song player. And if I hover over this, I can implement my methods here. I know that VS Code can do all the same stuff, but IntelliJ can do it too. And I don't know, I like to be able to do that stuff. Okay. So what I've got here is a class that implements an interface. How it's going to implement that interface is going to be something we'll get to in a moment. For the record, I'm not actually going to write code here that plays songs. That's kind of outside the scope of this course. But I am going to get us to think a little bit more about this. Okay, so you are somewhat familiar with interfaces already. You're somewhat familiar with interfaces already in that these are things that will have been provided to you. You are able to use them. You're able to use them as types. You're able to assign them. You're able to implement them. The informing of how we choose what goes into our interface here is very much what behavior do I want to expose for this thing? What behavior do I want to expose for this thing? We'll come back to this in a moment, but what I want to move on to now is records. One of the things that I need to implement in my system next is the song object. Song itself is going to be a class that has a bunch of attributes in it. And it fits really well into what a record in Java is. A record in Java is a special type of class. So I want to be clear that a record is a class. They are the same thing. They're the same thing. A record is a class, but it comes with some convenience features. The first is that it's very easy to declare and define a class by giving it a record, by giving it a name and then telling what the properties of that thing are. We get to write this in effectively one single line, and we don't have to spend too much time adding a bunch of stuff to that. All of the properties that we define in this definition have accessors. There are methods that are auto-generated for us, including a constructor, so we don't have to write the constructor ourselves. And all of the properties that are in this class are immutable. So they are implicitly final by default. And that effectively means that once I've initialized the value with something, I cannot reinitialize the value with something. I can't change the value after it's been initialized by constructing an instance of this thing. So I'm going to go back to IntelliJ, and I want to start adding a new record to this model that I've got here. So I'm going to do new Java class. I'm going to call this song, and I'm going to choose record here. Declaring a record in Java is public record, and then the name of the thing that you want to have here. And I'm going to just pop open my, my domain model diagram here very briefly, because I want to take a look at what the song class actually has in it. So my song class here has a few different properties. It's got a name. I'm marking this as string. We're going to use a string internally to represent this thing. It has a length. It has a duration. A duration is meant to be like an amount of time that this thing will take. We have a file, and we may eventually get to the point of having a genre for this thing. So a genre with a song is like going to be the subcategory of the kind of music that this thing happens to be. So I'm going to go back to song here. And the way that I can start adding these properties is to start putting them in between the parentheses here. So the first thing I want to have is a name. The second thing that I want to have for now is a duration. Java has a pretty extensive time API that is really quite good in terms of being able to describe different kinds of times and stuff. So that's all in the java.time package. And the last thing that I want to have here is where this file is located. So path file. This is going to be the file that represents the actual file on the file system in my folder structure for the thing that I want here. What we get from this is a set of methods available to us. We're going to get accessors for free. So there are methods on this type like name, length, and file. I want to make an instance of this class so we can see approximately what that looks like. And so I'm going to bring open my main file here. I'm going to pull it down to beneath song so that we can see them both at the same time. And I'm just going to delete all the stuff that's in the main method right now. So to create an instance of this class, I'm going to say song s is equal to new song. we have a constructor that's been generated for us, and we have to pass to the constructor in the same sequence that we've defined in the record. So name, duration, and the file itself. So, oh my gosh, songs. Okay, sure. The song that I was listening to on the way here is called uppercase CLUSTR 777. The duration of this song, and the way that I can get at duration is duration dot duration itself is an immutable type, and so the way that we interact with this is we use these static methods to get an instance of it, and then we use other methods to get other instances of it. So this song is duration.ofMinutes. It is 15 minutes plus 12 seconds long. And the very last thing that I want to add is a path here. So paths dot get, and I'm just going to say that this is called cluster 777.mp3. I'm going to put this on several lines so that we can see everything all at the same time here. So I've got an instance of my song. Once I've got this instance, I've already assigned the name to be cluster 777. I've declared or defined or initialized the duration of this to be 15 minutes and 12 seconds. And the path is going to have some file name that represents, this is where this thing is. Yeah.
Sorry, I'm not familiar with the name to dot coding parameter.
Just to make sure I understand this part right here.
Yeah.
So this is actually, I didn't type this. This is just the editor in IntelliJ showing that this is the name of that variable up there. Yeah. Some IDEs and some editors will do stuff like that. It will show you some meta information about the class that you're making an instance of, or the methods that you're calling, and the variables that they have as names. I thought VS Code did do something like that, but maybe I'm wrong. It does? Okay. I don't know. This is something that's fairly new for what it's worth. It wasn't like this when I was a kid. It wasn't like this when I was a kid. So I've got instances of that. I have accessors that have been created for me. So I can say system.out.println. The song length is plus s dot. And then I've got name, length, and file. So I can say length here. But once I've set these properties, I cannot change them. So I can't say s.length is equal to. There's no option for that. These are all final. I can't make changes to it. They're all hidden from me here. And there's also no mutators. I can't pass a different duration here. I can't say that this song is now 300 minutes long. Once I've initialized these properties, they are set, and I cannot make changes to them. So this is an immutable object. These are good in general, and I'm going to say that in terms of deciding what type you should use for your own domain model, if you know that the properties values in your class are not going to change after you initialize them, and this is going to be relatively common, Record is an excellent type for that. If you know that the values in your object are going to change over time, then you kind of need to use class so that you can make changes to these values as time proceeds. Okay, I'm going to pop back to my slides here. So we've got interfaces, we've got records, and now I want to talk a little bit about enumerations. An enumeration, and this is a pretty common structure in a lot of different programming languages, this is a way for us to describe a type that has a specific set of possible values that it can hold. What I mean by that is an integer says it has to be a whole number, and it kind of fits into this range. It defines what all those possible values can be. When we're thinking about enumerations, they're usually going to be some small subset of something to represent these ideas. So I'm going to go back to IntelliJ here. And what I want to add to this is a genre. So I'm going to make a new class, Java class. I'm going to add this as an enumeration or an enum. And I'm going to call this song genre. The way that this works for us is that we're going to just list the possible things that we can have as a value for this. I don't know about all of you, but I don't really like to use genre to describe my music because I just find it impossible to tell the differences between one genre and another, except for like really, really broad strokes. So forgive me for picking the ones that I picked here. You're also welcome to shout ones out if you want, but we can do things like pop, we can do things like rock, we can do things like country, we can do things like drum and bass. When I'm listing these things, I'm listing them all as uppercase, and I'm using underscores. These are effectively the same thing as constants. These are effectively the same thing as constants. And what I want to do with this ultimately is I'd like to add add something to my record type here that says what genre this is supposed to be. So I'm going to add a property to my song here called song genre. And if I go back to my main class now, I'm going to have to add that to the constructor of this. So I'm going to have to say something like song genre dot drum and bass. I think is probably the closest to what this song actually is. Enums are useful when we're describing things like there's a very fixed set of possible options for what this thing can be. These are useful for things like a kind of thing. I don't want to make a whole class or a record to indicate what genre something is. I want to have something that's just, this is a limited set of the possible things that you can choose for this thing. Another thing that you might see for the use of enums is stuff like flags or indicators to kind of say that this is the state that this thing is in right now. So there's going to be one of a few possible states that something can be in. Okay, so I'm going to switch back to my slides here, and I'm actually going to reintroduce this idea of our Pokemon domain model. And I want to start asking you some questions about these things. In this domain model, we've got our Pokemon printer. This is a class whose responsibility it is to print stuff for us, to print out what a Pokemon is. We've got our Pokemon type that represents instances of what a Pokemon is. We've got our trainer. This is that 12-year-old kid that's going out into the wild with their parents' blessing to just find strangers and have battles with them to gain money. And then we've got this idea of an item. Item is this thing that we can apply to Pokemon instances to make changes to properties that they have about them. I'm going to hold this up here for just a moment. And then I'm going to switch over to Mentimeter to ask you some questions about this. The questions that I'm going to be asking you about this, just to kind of set the stage for what we're about to do, is given those four things that I just described to you, interface, something you've seen before, record, something that we've just introduced today, enum, and class, regular class type, what are we going to use for each of these things? Yeah.
I had a question regarding how do records work? I think it conceptualized well.
A record, so in general, a record is a class. So that's broadly what we can say about it. It just means that we can define it a little bit more concisely. So this one line, I'm going to pop back to IntelliJ for just 1 second here. This one line effectively declares the entire class.
I don't have to use instance variables here at all.
The things that we're putting in between the parentheses here are the instance variables of an instance of this class. So I don't have to explicitly go through and say private name, private duration, private whatever. All of these things just get kind of created for me on my behalf by using this type. Yeah. Yeah.
So the constant in enumeration, like what kind of values do they hold? Do they have a value?
The constants that are in the enumeration don't really hold a value. You can actually add properties to an enumeration and you can like set values for those things. I'm going to say that that's a little bit outside the scope of what we're doing here. The idea with an enumeration is really that I just want to say that there is a type here and it can have these possible values without really specifying what the actual value underlying that thing is. So it's more an indication of I want to change behavior in something, or I want to indicate that something is like set for this thing without actually saying what that value is. Okay, so I'm going to head over to Mentimeter here. The questions I'm asking you are about the domain model that we've got here. This is the image that came up when I searched for the words Ash Ketchup. Okay, so awesome. Yes, class is definitely a good choice for this. I'm going to switch back over to my domain model diagram here. And I'm going to open this image in a new tab so that I can zoom in on what this thing is. A class is an excellent choice for this because things like money are likely to change as time goes on. This 12-year-old child wandering around in the wilderness, encountering strangers and battling them to get money from them is going to increase the money that this trainer has. The name of this trainer is never going to change. Once we set it, we're not going to make changes to this thing, or it's very, very unlikely for us to make changes to this thing. The two items that we've got here at the top, team and items, the team of Pokemon that we have and the items that our trainer has, these are indeed likely to change over time. One minor thing about records and their use is that while the properties in a record are immutable, and so what I mean by that is we cannot reinitialize them after we've created an instance of it, a list is not a primitive type. I can't do something like change the list to null after I've initialized it, but I can add things to the list. And so a class here is a reasonable choice. I think a record is also a reasonable choice because we have these different types here and it's possible to make changes to them because they are complex types internally. However, I'd say that the best answer here is going to be class for this thing. Here's another question. All right, okay. In this case, I'm going to say that the very best answer is the one that we selected already to represent what a Pokemon is. I'm going to go back to the domain model diagram here. Our Pokemon consists of health. This is the one property that we really have on this thing right now. When I'm choosing to use a record, one of the things that I'm trying to say to other folks like us, dev folks, is that once I make an instance of this thing, I don't really want stuff to change inside of it. In the example that we've done with Pokemon so far, what we've done is we've got our health, we initialize that to be something, and then as we attack this Pokemon, over time, its health is going to decrease. We didn't get to the point of apply potion to like make changes to the health again in the positive way, but the idea here is that once I've declared this class, I want to actually make changes to the instance variable itself. I want to make it go higher. I want to make it go lower. With a record, I can't do that. Once I've initialized health in a record, it's set. I can't make changes to it anymore. Yeah.
Why is it not interface? Wouldn't we have different types of Pokemon?
That's a good question. So the question is, why is it not interface and don't we have different types of Pokemon? So forgive me, I'm going to talk a little bit about Pokemon right now. Yes, there are different types of Pokemon. And so when I think of different types of Pokemon, I think of, it's been a really long time. There's grass, fire, electric, water, psychic, ground, ghost, normal, yes, thank you. Okay, that's it, because no, we stop at red and blue. We don't go past that. No, yeah, okay, dragon, okay. So there are 9 types. I can't count. There are 9 different types. Within each of those types, their properties don't change. Like they all have health. They all have moves. They all have a name. They all have a maximum health. They all have the same properties. And so in that sense, my idea would be that an interface here is probably not the right choice because I don't want to make them different classes. I want to make one instance of a Pokemon class or one Pokemon class type, and I want to use an enum to represent what those different types are within that thing.
They would just basically have different attack and stuff like that. The attack itself won't change.
The attack itself won't change, exactly, yeah. Or attack will be modeled as a separate thing entirely anyway, yeah. Yeah.
I think you might have just answered it, but does that mean we would use an enum to list every possible Pokemon and every possible type, something like that?
In this contrived example, yes, we would list every possible type of Pokemon as an enum, yes. That's how I would approach solving this problem, yeah.
All in one enum or?
So I would make like a Pokemon type enum and then list all of them out, yes, yes. But again, I stop at red and blue, so there's a very limited number of types that I have, yeah. Okay. Arceus, Pokemon God. Okay. You are wrong. Whoever you are, Arceus. Oh, nice. I'm right at the top. This is not fixed, I promise. It's not fixed. Okay, all right. Yes, 100% a class. That's a reasonable choice. A record is a class. So choosing class is kind of like, yeah, awesome. This is a slight trick question, so forgive me for this because I didn't tell you about this, but a record can have methods. You can define your own methods inside of a record. I want to show you that really briefly. I'm going to pop over here. I'm going to make a new class in my model. I'm going to call it Song Printer. I'm going to make this a record. And a song printer is going to look pretty similar to what Pokemon printer had. When I made a Pokemon printer, it accepted an instance of a Pokemon that I wanted to print out. So a song printer is going to be a song S. Within this record, I can say public void print. And I can say system.out.println song duration is s.length. And I can totally do it because a record is a class. A record is a class. I can have instance methods inside of this thing if I want to. I can also do weird stuff, and I'm not encouraging you to do this to be clear, but I can also do weird stuff like I can say that this record implements an interface, speaker song player. I can do this because a record is a class. I'm going to say that, and I'm going to undo all this stuff. I'm going to say that a Pokemon printer could be a record, yes. And I believe that this is a good answer. I think the best answer here is still probably class. And the reason I'm saying that is because of the intent that the type is carrying with it. A record is meant to be something that carries data, generally. The data, once initialized, doesn't change. A printer is like a verb type that I'm making. I want this thing to do something. And so I think that class probably fits best in here. I want to give some spiritual credit to interface because that's leading to the next question that I'm going to ask you about here. And the next question that I want to ask you about is the item type. This is the last thing that we've got. I'm going to ask you this question blindly. I'm going to give you a tiny bit more information, and then I'll ask you the question again. Okay, so I'm going to give you a little bit more information about item here. I'm going to assert that enum is probably not the right choice. I'm going to assert that it's probably not the right choice because while there may be a fixed number of items that I have, they're all going to do different things. And now this is me knowing a little bit more about the domain than maybe everybody does. When I have a potion, it changes the Pokemon's health. When I have oh my gosh, I forget all these things. Restore, I think it changes the state of the Pokemon from frozen to unfrozen or burned to unburned, that sort of idea. So while there are different types, and I'll give some spiritual credit to enum here, each of these different types is going to do a different thing. I've said the words, I'm going to have different types of items in this system. And so class, record, and interface here still kind of make sense. But I'm thinking about, I want to have different types of this specific type. And so I'm asking the question again. It's the same order. But given that I may want to have multiple types of this item type, what might be the best thing to represent an item? Okay, yes, so awesome. I might want to have multiple different things that are items, and what I really want to describe about with an item is what should an item be able to do? I want to start to specify behavior without actually saying what it does underneath. The things that are actually going to implement this interface are actually going to do that stuff for us. Oh no, I've fallen off the leaderboard. All right, congrats to Sam, whoever you are. I'm going to quickly pop back to my slides here. I know I've got minus 30 seconds, but what I want to say here is at this point, you should be able to make some choices about using appropriate language structures for representing domain model objects in your implementation. That is it for today. I will see you all on Friday. Bye, everybody.